Alright, so what we're going to be doing now is finding the area of a region between two curves using integrals. So if you're trying to find the region bounded by the graphs of x squared plus 2 and negative x, usually they're going to give you coordinates like x equals 0 and x equals 1, just so it's not an entire graph, especially here where they're never going to intersect. So what I did was I already drew the graph, and then, because that just gives you a window so you know exactly what you're trying to find. The first thing you're going to do is you're going to find the area of the integral from the point that they give you, so from 0 to 1, of x squared plus 2 minus negative x. Now when you're doing area equations like these, it's always going to be the top curve minus the bottom curve. And it doesn't necessarily have to be a curve, it could be a straight line like negative x, but it's just going to be the line that goes up higher, like the parabola is up higher, so that's what goes first, before the negative x. So your next step is just going to be to simplify. So you're going to have 0 to 1, and then you're going to have x squared plus x, because a negative and a negative makes a positive, and plus 2. Then the next thing you're going to do is take the integral, which is going to give you x cubed over 3 plus x squared over 2 plus 2x. And then the next thing you're going to do is solve it finally, which is going to be f of b minus f of a, with 1 being b and 0 being a, because you're going right to left, like with everything. And then when I do that, that should give me the answer to the area. It's not in any special units, it's just going to be the area itself. So f of b minus f of a. So like I said before, your b is going to be 1, a is going to be 0, and when you plug in 1 for the equation x cubed over 3 plus x squared over 2 plus 2x, you're going to get 1/3, because 1 cubed is 1, plus 1/2, because 1 squared is 1, and then plus 2, because 2 times 1 is 2, minus, and since they all had x's in them, you can just go with 0, because 0 times anything is 0. Next thing you're going to want to do is make a common denominator, which is going to be 6. So you're going to have 2 over 6 plus 3 over 6 plus 12 over 6, which is going to give you 17 over 6, which will go to 2/5/6, which is going to be your final answer for the equation, and that's your area. So next we're going to do a graph that intersects at 2 points. Well, actually 3 points, but it has 2 different sets of areas. So you don't really need to graph this one. There's another way to find what points you need to use, but these are the regions where they intersect. But, you know, the graph, if you feel like it's a waste of time for you, or you have a graphing calculator, then it's really not necessary. But another way to find it is just to combine the 2 lines that you have, which would just give you 3x cubed minus 2x squared minus 12x. And you can just find the zeros there. So you can just factor out an x, and then you'll have 3x squared minus 2x minus 10. It's not a 12. Still, that's so not a 12. And then when you find the zeros, you're going to get the x on the outside, which is going to be x equals 0. And then when you factor this, you should get x equals 2. And then x equals -5/3, which are the points here and here, where the graph crosses the x-axis, along with 0. So because we're dealing with something that has 2 different points of area, we're going to have to use 2 different integrals for each respective area. So our first one is going to be from -2 to 0, because that's approximately where this is. And that's going to be 3x cubed minus x squared minus 10x, because that is the top curve. Don't laugh at me, stop! Minus negative x squared plus 2x dx. And that's going to be plus the integral of 0 to 2 negative x squared plus 2x, because at this point this would be the first curve, or the top curve. Shut up! Plus 3x cubed minus x squared minus 10x. So what you're going to do is you're going to take the integrals of both, which is going to take a while. Okay, so the first one is going to end up being 3x cubed minus 12x, which is going to be 3x to the fourth over 4 minus 12x over 2. So that's just going to leave you with 3 over 4 x to the fourth minus 6x squared. Now the next thing you're going to do is take the integral of the next equation, which was 0 to 2, negative x squared plus 2x minus 3x cubed. Oh my god. X cubed. Sure. Minus plus x squared plus 10x dx. And then when you take the integral of that, it's going to leave you with negative 3 over 4 x to the fourth plus 6x squared. And then you're going to take f of b and f of a of the first one, which was 3 over 4 x to the fourth minus x squared. And then you're going to put them both together. Now, when you plug in b and a for the first equation, which went from negative 2 to 0, you're going to get, well, when you plug in 0, you're just going to get 0 minus, and then what it would be when you plug in the 2. So 2 to the fourth is going to be 16 times 3 is 48. Divided by 4 is going to be 12 minus 24, which is going to give you negative 12. This is going to be 0 minus negative 12, which is going to equal 12. And that's for the first integral. Then for your next integral, which was negative 3 over 4 x to the fourth plus 6x squared, you're going to get, you're going to start with from 0 to negative 2, so 0, you're going to start with 2 to 0. So when you plug in a 2, that's going to be negative 12, because it's just a sign change from here, and then plus what you get here, which was 24, which is going to equal 12. So from your first integral you got 12, and the second one you got 12, add them together, and then the area of both regions is going to be 24 units squared. Typically, it's not going to be required. It's a Z with a line through it. Typically, it's not required, but it's good to have units just in case. Alright, so this next one is special not only because it's in terms of x rather than y, but because at the point where these two lines meet, there's really no definite top or bottom line. Now, you could do it the way we've been doing it, just in terms of an alternate axis. Like, you could do an integral in terms of y from negative 2 to 1, which is the boundaries of this graph. Or you could do it the way we're about to do it, where you separate these in two in terms of x, because that's the way we've been doing it. Now, once you put it into regular y equals mx plus b form, you're going to have the integral from -1 to 2, because we are starting with this area first, of x minus 1, which is clearly the top curve here, minus negative rad 3 minus x dx, plus the integral of 2 to 3, rad 3 minus x minus negative rad 3 minus x, because in this area, it's just this line that's making up the curve. This doesn't matter because it's not, you wouldn't do this part because that's not part of the overall area, which is here. Now, when you're done taking the integrals of these, you're going to get 9 over 2. Because that's what you get once plugging them in, which if you solve the other way, just using y here instead of x, just like using the equation that you're given, you're going to get 9 over 2 as well. There's no, whatever makes more sense to you, you should use, because that's what's going to help you do well in the class. It doesn't really matter what you think looks more calculusly acceptable. Thank you. Thank you for your approval. I appreciate it. It means a lot to me. Because what matters is that you're doing well. Yes, and that's the answer, 9 over 2. This next part here is definitely the easiest. All you're going to be doing is finding the area under the graph, but from a certain point that they give you. So the first thing you're going to do is take the integral here, and when you solve for it, it's going to be 1 over 6 x cubed plus 2x. Now, it's actually going to give you t, but you just plug in x because that's what this is in terms of. So when this is 0, it's just a straight line down. There's really nothing there, so obviously your area is going to equal 0. Then when you have f of 4, you're just going to plug in 1 over 6, 4 cubed plus 2 times 4. It's going to give you 1 over 6 times 64 plus 8. Just plug that into your regular calculator. And that's going to give you 112 over 6, which equals 56 over 3 when simplified. And that's just this area over 4. Yes, perfect. Now we're just going to do the same thing, but with 6. So that's going to be like this and like this. Yes. Plugging it in, you're going to get 36 plus 12 gives you 48. And then you're done. That's it. It's really simple. It's really easy. Definitely the best part of this chapter, which is 7.1, if you have my textbook, which has a certain name. Next we're going to be doing section 7.2, which is going to be involving volume and the disk method. Well, thank you for your time. I appreciate your listening to my incredible video, which I'm sure has enriched your life greatly. Stay in school, don't do drugs, be the best you can be, and love everyone. The end. Finn.
I don't always differentiate x squared, but when I do, it's dos x. State arriving, my friend.